we're going to start with some basic definitions or some concepts that we're going to use again and again in this course. And that will give us some basic that we're going to talk in statistical language. So let's see what are the basic definitions that we need to know. Okay, basic definitions. First one is data. Data, when we talk about the data, you probably say, yes, I know what data is, or data are. And the data, you might think numbers, but actually it could be letters, like gender, okay, male, female, and things like that. So data can be any observation. We call that data. It's a collection of observations. Of course, when we talk about the data in statistics, the observation, we don't really use a long sentence or paragraph to describe our observations. We kind of like break down into different, we call that variables or categories or things like that. So data is a very basic concept here. And the next one is statistics. Statistics is a science of several things. You're going to plan how to do the experiment or how to do your study. So include planning, okay, and you're going to obtain data, and then you organize data, and then at the end you're going to draw a conclusion. All right. So these 4 steps, they're all very important steps in statistics. And let's see. I worked for credit bureau before, and what the statisticians are doing is they have to make a good plan. How do you collect the data? You have to think about what's the purpose after you get the data. What is the reason, or what's the purpose of your research? What do you want to do? What's your goal is? And also you have to think about how should I define the structure of the database so I can collect the useful data. Okay. And then the next step is to obtain data. The credit bureau obtain data from all different banks and financial institutions. And how do you get them? And once you get them, how do you put them together, right? And that will be the organizing the data. You put them in the data set, and how do you structure that? And of course, after that, there's one more step is to do study. And I should probably add it here. So you're going to summarize it, and then you're going to do some presenting to see what the data really mean, and then you're going to analyze, and at the end you're going to interpret, right? Okay, so every people think, oh, this is the most important thing that statisticians are doing, but actually this, and the last step, they're also important. And the last one is to draw a conclusion. Just keep in mind that most of people, they're not a math major or they're not a statistician. So when you come up with a conclusion, you have to really explain that to the people, either in business or in daily life or in some kind of other industries. So that is data and statistics. All right. Next concept, I just keep moving. The next one is called a population. And compare with the population, we call that sample. Okay. For example, if you want to find the average income of everybody in the United States, and what would be the population? Population is the complete collection of data, which means you have to go through every single person in the United States to get their income and get all those numbers back together and average that so you can get the exact number. So the population is everybody's income. However, I know you don't want to do it. It takes too much time, it takes too much effort or too much money, or sometimes it's just totally impossible. So we have to use a sample. Sample is a subset of population. So it's a part of the population. So you're going to choose the sample, or we call that a sub-collection of members selected from a population. So this is a part of the population. You see the difference between these two? Population is everybody in the universe, and a sample is just part of it. And we use this, we get the data from here, so we get some conclusion about the population. That's a general idea. And for the data collected for the population, there's another word. You probably heard this before. It's census. Census, that you probably heard of Census Bureau, right? Okay. So census is a collection of the data from every member of the population. And of course, a sample data is only part of it. It's like the subset. All right. Now, other than this, we're going to talk about the 3 steps in statistical study. So 3 steps in statistical study. All right. Now, step 1, we call that a prepare. Pretty much like you're planning, right? You make the plan. You're gonna prepare. You have to design the experiment very, very well before you start doing something, because once you start, it's really hard to go back, and you already started. And also when you finally found, oh, I missed some data, or I should have collected this and that, then you have to go back to the beginning. You waste time and money. So when you prepare, you have to think, what I really want to study, and how should I collect the data, and from where, or the source of the data. And the other important thing, sampling method. So sampling, how do I get a sample from the population? So that's a prepare stage. And once you have all the data, the next step is analyze. Okay, you're going to analyze data. You have seen so many different statistical reports. I believe you saw graphs. Most important one, right? Pie graph, or bar chart, or histogram, those pictures that kind of show you what the data looks like. And explore, you might want to do further study of the data to see if there are any important findings. And also, you're going to apply your statistical methods to the data you collected, all right, to do the analyzing. And the last step is to conclude. This is a step you're going to come up with some significance interpretation. Just give me your conclusion. Okay, is this normal? This is abnormal? And you see there's some relationship between them. And what did you find? And how do you make the prediction, or some data you collected is very, very important when you make the prediction of the future behavior, things like that. So that would be the last step. So when we talk about this sampling method, there are several sampling methods. For example, there's a random sample. Random sample, that makes perfect sense, random, because it's really just random. Everyone has the equal chance to be selected. For example, if you want to know the average age of all college students, all the college that you work for or you are at, let's say there are 20,000 students there. I'm not sure whether that's the right number, okay? So this 20,000 students is the population. However, if you want to find the average age, you should to go ask every single person, or you should collect all those 20,000 numbers from each of them, and then you average that to get the age, right? However, you cannot do that. Of course, you don't want to do it, so you're going to do sample. So what about a random sample, which means every single person of this 20,000 have the equal chance to be selected. Let's say you only get a sample of 200. That sounds like a good sample size already. So this 200 out of that 20,000, this is the good sample from the sample size if you want to choose a random sample. So that's a random. And there's another way called a self-selected sample, or voluntary response sample. For example, you just set up a little table in front of a building and just ask students nicely, say, I'm doing a research of something, and could you please come here and write down your age? So someone said, oh, okay, I like to help. So they just write down their age, and some just walk by and just take a look. They don't care. Okay, so those sample data you collected, we call that a self-selected sample. And there's some other things like a convenience sample. For example, you only go to school in the morning, you take the class at 9 o'clock. So you arrive at school at 8:30. So you spend this 30 minutes to collect some data, and that's a convenience sample. Or systematic sample. Let's see, you go to I don't know, let's say you have a 200,000 students, you want to get a 200 out of them. So if you have the students in order, so you're going to choose the number 1 and number 101, say number 201. So every 100, after every 100, then you choose the sample. So that is also a random sample, because the number each people get is also random, right? Or I don't know, there might be an order, but anyway, this is considered as a systematic sample. It's also a good representative of the population. And there's another one, cluster sample, means you're going to choose a sample from smaller groups. For example, 8 o'clock, 9 o'clock, 10 o'clock, until like all the way to 3 o'clock. You stay at the parking lot, you ask the people who arrive at that time and ask 5 students or ask 10 students about their age. So that's called a cluster sample. So there's all different ways to get a sample from the population. As long as you can convince that this sample is representing the population, we would think that's a good sample. So it doesn't really matter which sampling method you select, then you want to make sure that it's a good sample representing the population. All right, now the significance, that's about the sampling method. And the significance, that is when you get the conclusion. And there are 2 significance. One is called statistical significance. Significance. And the other one is a practical significance. Okay, these 2 are different. This one, statistical significance, if likelihood of an event occurring by chance is 5% or less. Usually 5% is like the magic number. You're going to see that almost like all the time in this class. So if something happens and the chance of that happen is less than 5%, and we call that is a statistical significant. Okay, and the other one, the practical significance, that's by common sense, suggests that the finding doesn't make sense or worth it. So that's a practical significance. So something doesn't worth it, we don't really need to care, or something doesn't make sense, we don't need to care, or the chance is really low, things like that, and then we don't need to do that. That's called a practical significance. But anyway, so don't worry too much about that. And in this book, we really cared about this a lot, statistical significance. All right. The other thing about the conclusion is there's one thing I want you to know. Let me just move this a little bit. Okay. That is a correlation is not equal or doesn't imply causation. What does that mean? Just means 2 things happen together. It doesn't really mean that one is the reason of another one. A very typical example is this. A very typical example is if you look at the time from January, February, March, and all the way to December. Okay, if you look at this, and you look at the ice cream sales, and we know that in summertime, the ice cream that people like ice cream in summer quite a lot, right? But in wintertime, it's not that much. Do you notice? Okay, things like that. So once you draw like a curve, you probably will see something like this. So during this summertime, more people buy ice cream, or the ice cream sales number is pretty high. In the other way, if you also look at the number of the number of drawings in a year, you put them in different months, and you also look at the numbers, you probably will see pretty much the same pattern. Because in summertime, people like to go to river, lakes, I don't know, river, lakes, ocean, wherever, near the water to have fun or to cool down, to enjoy themselves. And then so the number of drawing goes up in summer, and when it's cold in winter months, people really don't out to swim a lot. So therefore, the number of drawings is not very frequently occurs. So you're going to see that they pretty much have the same pattern. However, you cannot get the conclusion of one is the reason of another one, because it just happened. They just have a relationship. There's a correlation between them, but it doesn't really mean one is the reason of another. You cannot just stop the ice cream sale to reduce the number of drawing, right? So that's one thing that I really hope that you can remember. The correlation doesn't equal to causation. Okay, so I think that's everything about the basic concepts that we need to know.